We've learned the basic formula for a linear function is y equals mx plus b. We know that m is referring to our rate, a rate of change. We know that b is referring to our y-intercept, and we've learned other ways to talk about those too. What I want to talk about in this video is how can we come up with a linear function of the form y equals mx plus b when we're given a graph. So on the graph in front of you, we've got three different functions. All of them are linear because we can see from the graph that they are all lines. What we need to determine are those two things. We need to figure out what is this rate and what is this y-intercept. The y-intercept is actually quite easy to find because it's where your line hits the y-axis. So let's start with the blue one. We'll call this our first function. Y equals, well, it seems as if it hits right at the origin, which is 0, 0. So it seems as if our b value is actually 0. For now, I'm going to put that on there. Our second equation, let's call the pink one our second equation, also hits the y-axis right at the origin. So if we're going to come up with an equation for that, it also is going to be plus 0 for our b value. Our third one is this green one coming down. It looks like it hits our y-axis at 12. So we've got plus 12. There's one part for each of our functions just based on what we see in the graph. Now finding the rate is just a little bit more challenging, but basically remember what we've said. This is saying how much is our function changing per x value. So if your x value increases by 1, what is happening to your whole function? If I go back to line number 1, what we can see is if I increase my x value 1, it looks as if my function has been raised 1. If I go again another x value of 1, my function again has been raised 1. And it doesn't matter where I do that. If I start here and increase my x value by 1, my y value goes up 1 unit as well. This is telling us over and over and over again that our rate of change is 1. So in our equation, we can say y equals 1x plus 0. And we've said before, if the coefficient, or this rate, is 1, we can actually drop it off. And in fact, if the y-intercept is 0, we can also drop that off. So we get a very, very simple function that y equals x. Whatever the x value is exactly what the y value is. For our second function, if we look at an increase of one x value, it actually goes up 1, 2, 3, 4 spots. If I check over here at another one, x value increases 1, my y value goes up 1, 2, 3, 4. Right? Since it's a consistent growth and it's happened 4 already twice, we know that that rate of change must be 4. So for every x value that increases, my y value is 4 times larger. Again, our y-intercept is plus 0. We can take that off. Therefore, our linear function is y equals 4x. Our last one. We can see as our x values get bigger and bigger and bigger, our y values are actually getting smaller and smaller and smaller. That's a good indication that we have a negative rate of change. We just need to figure out how much is that. So let's start here. Let's increase our x value 1. As that gets bigger, our y value actually seems to drop 2 units. Let's check another spot just to make sure. All right, I'm going to increase my x value by 1. My y value, sure enough, goes down 2. So our rate of change is negative 2 for every single x value plus the 12, which was our starting point. This is how we would take our graphs and convert them into our linear functions.